Hello, folks. Mark Wilkinson again for the Pump Seal channel. I never get tired of talking about braided packing. I guess that's my wife would take offense, but this is my first love, and we've done a lot of great things with it over time. SealRyt is unafraid, basically, to try new things, and sometimes we struggle and sometimes we break things, but we always have fun at it. And it is you that apply this and use it who tell us whether we've hit a home run or whether we need to go back to square one. But if you look at our product line in general, you're going to find things you've never seen before. So not only are they described differently, but they defy pigeonholing. And the reason is we're just not involved in the business, the commercial side of the business, which is manufacturing the thousands of pounds that go into industry, and certainly on a price basis. And they're more or less generic. They become generic, just like asbestos used to be generic. Well, that isn't our business. So every now and then we develop something new and exciting. We get patents on them and so forth. Not that that matters, but today I want to talk to you about something that was actually developed for someone else. And that someone else is a company called Andritz. So Andritz, in the division that we work with, is based in Austria with manufacturing in Finland. United States has a presence all over the world. They are the largest pulp mill equipment supplier, but they had a problem. Every company has a problem. The pulping industry got to the point where they were rather arrogant, especially from Brazil. Are you listening? And the Brazilians wanted $1 billion install, and here's the problem. They required that anybody bidding on this project be able to guarantee and warranty everything. The equipment, the performance, for 18 months. Oops. The industry was happy to get 1 year out of the packing in their outlet devices, top separators, steaming vessels, high and low pressure feeders, and so forth. The big, slow, nasty equipment. Lucky to get a year. So famous were these pieces of equipment for yielding sleepless nights that millwrights and management would walk by and look at the gland followers to see how much they had left and try to guess whether they had that magic month or magic week to shut down. True. So here we are, 18 months. Well, now that's interesting. So we saw it as a real challenge. Decidedly a purpose-built material. Something that likely wouldn't be usable in any other areas. And here's how we started. So in a stuffing box, you've got packing, X number of rings, you've got lantern rings, you've got all kinds of things. Our first approach is always with our shaft stabilization technology. So this is just a straight packed application, but normally you would find our bearings all the way at the throat out through the lantern ring area. Then we'd be concerned with just this. What the mills were experiencing was consolidation. So you take Garlock 5000, which was probably the most dominant product out there, and there are many, many others that did the same thing. Carbon fiber soaked in cat squeezings and duck goo and all that stuff. And all of the products that were used were heavily entrained with air. The voids filled with these lubricants, if you want to call them that. What would happen, though, is that the gland followers, turn this vertically for an outlet device, the gland followers would start to leak and then would be adjusted. Squeeze, 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 squeeze. As soon as liquor would come out along with water, squeeze. Water was coming out, let it go. So what I referred to was that this follower would come up here and it'd be almost used up, and it wasn't shutdown time. So, in order to get a product, whether it's 3 rings of it or 5 rings of it or what have you, to do this 18 months and to do longer, we're now up to 5 years, okay, in one vessel. So, a single vessel. 3 is not uncommon. What you have to do, you have to design the textile, so-called soft portion that's doing the frictional sealing in here in such a way that it flattens adequately to seal, but isn't compressible. So the word consolidation is the enemy. So you got to design something that has incredible body to it, okay, but will totally resist consolidation. That's the key. In order to do that, you have to look at the braiding symmetry. If you look down on a table, a braider table that has, in this case, 36 carriers whizzing around, etc. And so these things are whizzing around and they're connecting through the braid. And at the same time, braider tables are laid up in quadrants. This quadrant is the same as this one, is the same and the same all the way around, but they're in quadrants. So within this quadrant, you have fillers, you have corner posts, etc., etc. You have centers, you got a round hole here, etc. You have different positions that you can do things in. Here's the problem. The same braiders that make 3/4 inch packing, 1 inch packing, 1.25 packing, also make 3/8. Okay? 3/8 packing square, 1 inch packing square. See the difference? Now, if you go to your shelf and you pick out any 3/8 packing, don't care. Squeeze it. Pretty hard. Pretty hard. Now go get a piece of 1 inch packing. Oh, softer. Huh, why is that? That is because each one of the carriers that are braiding this have a tension mechanism on the individual yarns. The Rockwells have a weight that travels up and down the carrier, always keeping tension on those yarns. Average weight varies between 3 and 4 pounds per. Overhead braiders utilize springs typically, and you can change springs, but there's a max amount of tension you can put on those yarns. Okay? So here with a 3/8, you use single filament stuff, single fiber stuff. Each one of those weights is pulling down on it. You get that thing taut as a banjo string. On the 1 inch, each bobbin goes from 1 yarn to 3 or 4 or 5 yarns. Now that same weight or spring cannot pull with equal tension on that many yarns. So what happens? You still get your 1-inch packing, but it's not as tight. Okay? If it's not as tight, you then have entrained air. Well, to get yourself 18 months in one of the most rigorous applications in the world, which is fiberline equipment, you can't have entrained air. That has to be solid. And it can't be solid with fillers, lubricants. Okay? Because that is temporary, and that leads to consolidation. It's got to be filamentary. So taking the design aspect, what are we dealing with? What are we trying to accomplish? Whatever we accomplish in the quadrants, we have to section out this way. That's not symmetrical. We have to section out that way to make sure that this area, this key area, is just as dense as this area on the outside. We have to make sure this 1-inch packing is just as dense as that 3/8 packing. How do you do that? Well, through our famous pre-twisting methods, which if you come to the factory, we'll be glad to show you how we do it. Variable speed equipment that can allow us to combine things, combine textiles, etc., in such a way that we can get a density by varying the number of twists per inch. Okay, what's the difference between a single steel wire and aircraft cable? Have a look at it. You tell me. Okay. So, what we achieve, and it took us 7 textiles to do it, to find out we're racking our brains with everything that's available on the market for yarns, textiles, fibers, filaments, all that kind of stuff. There's nothing in existence which all by itself can be braided, even with altered mechanical techniques, to give you the density required to stand up here and stay 1 inch. Okay? So, starting at the very dead center, not from the outside in, from the dead center, if you look at it, and I will show you a piece of it right here. Your eyes will pick up different hues, different colors. You'll see some silvery, glittery stuff. You'll see a yellowish polymer. You're apt to see individual carbon fibers in there, some nondescript stuff that is just smooth. That's 7 different textiles, starting with the center, to produce a material which is that dense. So now, when force is applied on this from the outside, the entire body resists that. It's not cheap. It's expensive. It takes 3 days for all the setups to come together to go to the braiders. 1 person, 3 days to get the whole thing set up. Yeah, 2 people faster, 3 people faster, etc. But it is a process that is required to get you where you need to get to. Okay, so let's talk about a few other things. Well, aside from being the standard product, both in rebuilding and new, in the fiberline business, others have tried and taught us something about this product. And that is, it is also very useful in large, slow rotating equipment in entirely different processes. Okay, not just the pulp and paper industry, but also where you're able to keep your surface velocity to somewhere below 500 feet per minute, 550, somewhere in that range. This material is so dense, it just doesn't compact. Okay, so is it food applicable? No. Is it nuclear? No. But just about everything else. Okay, so whether it's mining, okay, even some sugar plants, we're utilizing it in sand and gravel. Anytime you have a large piece of equipment that is rotating slowly, okay, high pressures, you could probably bring this material up to in the vicinity of 10,000 psi without any concerns at all. We'll see what the limit is, but for now, it's an absolutely incredible product. If you want to know more about it in terms of what it can do, but also what it can't do, we're very open about all of those things. Give us a call, and we'll talk about that. I will say that it is very different as a material to actually handle. So as a result, 99% of this goes out as cut ring sets. There's a very different technique that we use, that we have to use. So the best way to get involved in this is to give us the shaft size, the bore, and number of rings you need. We'll take care of the labor part of that. It's going to be accurate. We just don't want any mistakes with it. So this is now all over the world, and New Zealand, Australia, and Japan, Korea, Finland, Sweden, Norway. It was in Russia. Well, and South America, Chile, Brazil, Uruguay, etc. Big time Canada, U.S. But there it is. Only consider the genuine. But give us a call and let us show you how it's done. Come to the factory again, and be glad to show you how things like this are put together. Okay. Any questions? Don't call me. Call Seth. So anyway, nice to see you folks. Have a great day, and stay tuned for the next one. Oh, on the next one, I just may explain to you why it's harder to seal large equipment than it is small equipment. Why it's harder to seal slow-moving equipment than it is high-speed equipment. So, don't go away. More coming. Bye.